confidential information in the background there. Yeah, I don't think you can really see what's going on.
It just looks like a lab.
Great. Lab, yeah. And it has some client hardware on the tables. Okay. All right, so for this session, I have some good news and bad news. So the bad news is I sort of ran out of time and did not actively get through the simulation tasks as I wanted. However, the good news is there have been a number of passive updates which are actually strikingly relevant. So first thing is I have a GPU on the way. So Eric and I are going to be GPU buddies very soon. I got the 3090 with 24 gigs of RAM. So it should be quite enough for our purposes at the minimum, and then some of the other simulation interests that I currently have. So that'll be here tomorrow. It took a while. It was a little eBay graphics card. The other thing that happened that's very relevant is I went to a event last week for Silicon Valley Robotics. It was called the, I believe it was like the Robotics CTO Forum or one of these things. It was with Silicon Valley Robotics. It was located at Pier 9, the Autodesk office down on the Embarcadero in San Francisco. And they had a talk that was extraordinarily relevant. It was a talk for an entire hour about URDF, specifically about URDF and the challenges associated with URDF. So the first thing I'd like to do is just share some of the output of that event that's relevant and interesting, and kind of go through my notes. Let me pull up my notes. Okay.
Do you have any link to the event or something like that?
Sure. Yeah, I can talk a bit about the event as well.
We can do that later too. Huh? It's for references. Maybe some slides are also available on the website.
I would have shared the slides immediately. The slides that were presented about the format were actually out of a research paper that is soon going to be published. If I could ask the author if it would be okay to share it now. An email was sent out and it just explicitly stated not to share more widely since it's pre-print. But the paper will be published soon. This is
yeah, it could be, IP issues,
Yeah, here, let me.
Link. Is it already on archive?
No, I don't believe
Maybe there's
so.
an abstract somewhere. It shows abstracts.
Yeah, okay. I'm gonna mark it on my notes. I will share the paper with you guys if I can now, or I'll make sure that it gets forwarded when they do publish it, because it was pretty interesting. The main thing, okay, here are my notes, fine. The main thing that they talked about was actually usability, and they have hard data. They did a bunch of surveys and gathered a bunch of hard data that had a few main takeaways. The first was that people self-described the URDF as straight up difficult to use. And that not only is it actually difficult to use, there's a lack of actual tooling to create an easy pipeline. So that was the first issue, is that it's straight up a very fragmented format, and the tooling to use it are very fragmented.
Can I just ask, fragmented for people like us or fragmented for people like you?
Both. So this is like people who use the format regularly complaining about it.
Mhm.
This isn't like
This is- So may I
yeah.
ask what fragmented means here in the context? Because URDF is an XML format to define the 3D shape, for example. And what means fragmented in this context?
By fragmented, I mean, so there's a number. That's a good question. Let me present the ROS. Like if you Google URDF, this is the first result. And I think it kind of gets into the few things. So the first thing is that URDF is not feature complete. There's a couple things that it doesn't do. And maybe for some background, URDF is a description format that allows the description of a robot system. And it incorporates both kind of like the 3D assets as well as information linking the assets together and how the robot is kind of like mechanically defined. One thing that comes up is this YakRover. Have you heard of YakRover, Eric? So YakRover, if you look at some of the URDF models that are shared from the robot companies, they'll use this macro language they call YakRover, which is a layer on top of XML. So it's a way to programmatically define the contents of an XML file. So it's literally called the XML macro language. And to me, this is what I'm calling fragmentation. This is somebody who is using straight XML and it was not ergonomic and extensible enough. So we now created a new language on top of XML where we can actually have these programmatic macros where we can define like variables and things to fill into the format. So that's just an example. By fragmented, I mean the format didn't do what somebody wanted to do, and then they added more stuff to it, which kind of pulled it further in one direction into their preference when other people want to pull it a different direction to their preference. And so there's a lot of tension pulling it multiple directions such that there isn't a converged effort to create a ergonomic format and ergonomic tooling to use the format is what I mean by fragmented.
Yeah, so this is a common problem in
Okay.
ROS, not only in just the URDF.
Exactly.
So they have a custom build system called Catkin. Catkin basically builds on top of CMake. so they
Yeah,
have built.
exactly.
So it's like not just common in the URDF. It's just all around ROS like that.
But it's very interesting that it's happening in URDF. I would say it's way more interesting that the same issue is happening in URDF over like the build system, because Catkin is specifically a ROS thing. That's like unapologetically part of the ROS framework if you are a person who uses ROS. URDF is intended to be a data interchange format that's neutral between systems. So this is why we're having these issues, because it's kind of like the ROS way of doing things that's affecting a format that we actually want to pull out of Onshape, SolidWorks, all these mechanical CAD systems. And then it has to go into other data ingestion systems. Because like the fundamental issue here is we have a source and a sink of data. And usually the source is going to be the mechanical CAD system where we designed the robot. The sink of data is going to be often ROS, other simulation environments. Now it's NVIDIA. And there's all these layers and hoops that it has to jump through for that data to flow. And the thing that came up a lot in the discussion was the unavailability of a URDF model from vendors. And one of the number one places that people want a URDF model that can be hard to find is with industrial robot arms, it turns out. So if you want to simulate an industrial robot arm in ROS or Isaac or whatever, it can be a struggle to just like get a model of the robot. You're gonna have to go build it yourself. And so it's part of it is trying to get these large incumbent vendors to have buy-in to a format which, yeah, to your point, is suffering from these usual robot project problems. And there's this huge disconnect between those two worlds. So yeah, I would say it's like way more edge case to be expecting a large incumbent like KUKA or ABB to support, ROS tooling. Whereas I think URDF models are a little bit more neutral and universal. So I think I just consider it to be a different kind of case, because more people have skin in the game, or more people should have skin in the game. Okay, so we've talked about URDF. The thing that I did a little bit of reading into during the talk was the other formats that are around. So URDF is a very common one. There's another format called SDF, which is used specifically in Gazebo. So if we look up, also if we go to Formant has a nice page about URDF. So, this is their docs. I will post. Should I put these in the Roam? Would that be helpful? I could repaste some of my notes into the Roam.
I put them in room already. Yeah?
Okay.
As you talk.
Very
So
good.
is URDF widely used in the industry? Because I've only used it in like academic context in ROS.
The thing is, there's a overlap, right? Like there's industrial robot arms being used in academia, so that's part of that tension. So literally, Formant has a page about it, and one of the most sought after, kind of like, I wouldn't say sought after, but one of the most widely used robots in research, I would say, is the universal robots, the UR5. So they literally have an example of a UR5 here, and that's like a robot you would want a model of. So Formant has this nice little page that gives a blurb about URDF. They don't talk about like the foundational issues with URDF and problems it's trying to solve, but they talk a little bit about it, and they have this really nice list of links to common robots that have URDF models available. And like, if you go look in here, it's often going to be like, literally a GitHub page, and it's going to have URDF stuff, and it's often going to be in, it's going to have the YakRover format and ROS. But anyway, would highly encourage having a link to the Formant page, because they have some good, you can start there and look at some actual models from vendors that do provide them, that is, because again, the issue is a lot of vendors don't provide them. So there's the SDF format. I don't know as much about the SDF format under the hood. I just know that Gazebo Sim is pretty partial to it. It looks like it's also XML, but
Yes.
yeah, a little bit different flavor. Okay, so that's URDF and SDF in kind of like the open source world. The very relevant format that we actually didn't really have an opportunity to talk about in the forum, and the author of the paper didn't really bring it up either. And I feel like it's probably because it's still pretty new and niche, is NVIDIA's format. It's actually pretty funny, because there was a guy at the talk he's a researcher at Autodesk who is president, and he actually was at Willow Garage in the very early days, and he kind of like co-authored the first versions of the URDF format. So he was kind of in this talk where everybody was complaining about URDF, and then he picked up the mic and had some interesting things to say. But he was actually the one that brought up the USD format that you're going to encounter with NVIDIA. I kind of joke that the USD format is fitting because it's coming from NVIDIA, and their graphics cards are terribly expensive. So you need to use the USD with their hardware. So I believe USD is Universal Scene Descriptor. And this is this is the format that they want you to do the data interchange with. The USD format also, I believe it was jointly defined in a consortium. I think Pixar was involved in the early development of the format. And if you read about it a little bit, it literally says here, originally developed by Pixar. So the big claim to fame for USD is it supports, you know how if you open like a Photoshop file or a Illustrator file, and there's this notion of layers in the 2D data, so you can turn on and off layers in the 2D data. USD supports turning on and off layers in the 3D data. And that was kind of like the novel feature of USD that made it powerful for the VFX people. Because remember, USD is also used in like Maya, and Maya is, you know, one of the really big pieces of software and animation and sculpting and things. So they want you to use USD. They want you to move robot data around in USD. Like I said, I don't have my card yet, but the Onshape to Isaac importer that NVIDIA wrote, I don't know if it actually spits out USD or not, but I think that's kind of the next question. So those are the three formats that kind of came up in discussion at the forum. USD is kind of the new one and the outlier.
Joshua, a quick question is that URDF is a model to describe robots, right?
Yes.
Yes. It seems to me that there is a different scope because I've started to study SDF last week, actually, because, you know, as you know, I'm working on Gazebo right now. And SDF is a scene description format, and same USD is a scene description format. So it doesn't seem to be the same scope, in the sense that the SDF and USD are really about describing the world, okay, in which we can import a URDF robot model, for example. So I don't know much more than that, okay, but I wonder whether they don't have they don't have the same purpose in the first place. It's a model of a robot versus a model of a world, basically.
Yeah. So again, I'm also still getting current myself. Yes, you're completely right that they do have a little bit different use case. However, my understanding was that they all support the notion of a scene graph. I know URDF supports more advanced kind of descriptions of relationships. Like I think, in my understanding, URDF supports more. It's much more extensible as like a descriptor framework specifically for robots. But if you do have a scene graph describing the relationship between bodies, you know, there's like an offset coordinate in the scene graph. You can exchange a lot of 3D data that way.
Okay.
So that was my understanding. Yeah, the OG URDF guy also brought it up, that it is kind of like a new and up and coming data interchange format. But yeah. So that's kind of the summary from that discussion.
Okay, thank you.
Let me see if there's any other. Yeah, I also wanted to touch on from my notes about the tooling. Yeah, the tooling is also what I would say fragmented, because one thing that came up in the discussion was that some of these robotics companies are even building their own internal tools to deal with moving the data around this URDF interchange format. So there's the Onshape to Robot, which is the open source public repo. And I know a company that's actually using that quite a bit, and they've improved it and extended upon it themselves internally. And like they're thinking about even contributing back and pushing their changes to the repo. So there's that piece. I also, as an Onshape ambassador, I hang out with a lot of Onshape kind of like power users. There's like a Slack where people hang out. And I posed this question a couple times about Onshape and robot stuff, because there's definitely, it's like a vibe now that there's a lot of robotics companies that use Onshape. I would say that. I feel like there's been kind of a adoption is pretty real in the robotics companies. Excuse me.
Is there any particular reason for it, do you think?
So there's lots of reasons why Onshape is getting adopted. As to why it's preferentially getting adopted in robotics companies, that one I can't quite put my finger on yet. I could tell you all kinds of reasons why Onshape has its advantages and things, but yeah, for the robotics, I don't quite see it yet. One thing that might be part of that is what I was going to say about this ambassador Slack is I've been posing these questions about, hey, is anybody here doing work with robotics? Are you building any tooling around Onshape that does robotics stuff? So this is all very public. AvidBots is a very big Onshape user. They make a autonomous industrial floor scrubber. So it's like, it used to be the one that somebody would sit on and had the little steering wheel. This is just like an autonomous commercial floor scrubber for the shopping mall. I actually have chatted with them, and we were doing some studies to see how fast we could load the model, because their model is like it's like you're down to every nut and bolt. It's a hardcore Onshape model, and yeah, because we were benchmarking like how fast can you actually open like a multi-gigabyte model on Fiber, and yeah, works great. It's very performant. It's able to open up the model, and it's really quick. So that's like regular, just like MCAD stuff. The thing that has come up though is there's somebody who is specifically writing a Onshape to like ROS exporter. It's way better than the current open source one. It's not released yet. They're trying to keep me in the loop on it. I don't know if I can share much about it yet because they're still being a little bit cagey, but this is like a thing that they're building and working on, and it wouldn't be like an external tool like the Onshape to robot thing that sorry, I still don't have a live demo of it. But yeah, the Onshape to robot tool, you have to like run as a script on your computer, like in a Linux terminal, which is annoying and not very ergonomic. So the solution they're offering is like an integrated into Onshape extension, which is one of the nice things about Onshape is you can write extensions that plug into it very intimately in the cloud. So they're writing like a cloud-based robot export tool, which is pretty exciting. And I do know there's a URDF exporter for SolidWorks. I have not done anything with it. But I would expect, yeah, so they have it's an actual add-in into SolidWorks, which is kind of nice. Functionally, this is going to be similar. It's going to be like, it's an extension that you can have in Onshape in the browser where you can export your robot model fully cleanly and easily. So that, I think, if they actually do ship that, that'll be a big one, an example of one tool that is concretely useful specifically for robotics in Onshape. Because the power of that, to answer your question, is you could have, one thing that people do is you can just put your model of your product in Onshape. Like this is something they actually did with ODrive. I could show you real quick. I wouldn't necessarily recommend this, but this is something that Odrive's trying, and it's been kind of interesting to see how it works. So instead of actually having a link to the CAD files themselves, the product info with the CAD information is literally an Onshape document. And so we wrote a little tutorial here telling you how to pull out the data, and you can go in here and actually see a live model in 3D and mess with it and download it whenever it meets your needs. So why is this relevant? This is relevant because let's say you actually did wrote the URDF exporter extension for Onshape, and it could all be right here. You have the live model, the live CAD model running right here, and you can click export URDF. And the nice thing about it being a live model is before you downloaded it, you could, let's say, change the configuration, turn stuff on and off. Like that's one thing that's nice here is we actually have configuration set up. So you can kind of see the product configured this way. You can see it this way. And then you can click download URDF. And then now you have up-to-date URDF model with exactly the stuff that you want in it. And this is all in the browser. I didn't have to download anything, install anything. It's extremely ergonomic. So that's what I would say could be the potential power of using Onshape in a robotics application, as an example. Okay, so that summarizes what I had to talk about the data interchange format. There was one passive update that is specifically relevant to Venkat, because I know you're also running an M1 MacBook. So I don't know why, because I talked about this before. I don't know why I struggled so much. But the easiest way to get Ubuntu on an M1 MacBook that works flawlessly is just to use multipass. Canonical is now pushing pretty hard their multipass kind of like installation manager to run different Ubuntu images, and it's awesome. It's rock solid. You can just download and have Ubuntu running in a couple clicks. The one thing that's a little bit kind of weird about it is it does not include out of the box a like a window manager, or not window manager, but like a VNC or a way to view the screen of the image. So what they actually have you do, and this is also relevant to your RTX server, Eric, is you download vanilla Ubuntu, then you can install a Windows server, which is like a line or two, and then you remote desktop into that machine. Now on your MacBook, you would just download Ubuntu, install Window Manager, and then use RDC. So use Microsoft Remote Desktop to locally remote desktop into that virtual machine that's running. And it just works. It's really clean and very, very easy. So that's the M1 MacBook user specific update. But multipass is also it's multi-platform. I don't know if anybody else has used multipass much, but it's pretty good so far. I'm really impressed. It's like very ergonomic over like any other virtual box or these sorts of virtualization things. I could. Has anybody else here used multipass? They tried it?
So how is it different from this virtual machines like VirtualBox or VMware or Parallels, I think, for Mac?
One, it's completely free and open source. So that's the first thing. The second thing is it's like very lightweight. Like to install it, you can literally run brew install multipass, and it just installs the whole VM environment. One command. If you have brew installed as a M1 user, as a MacBook user. So free and open source, very, very lightweight and ergonomic to install. And then the speed and ease with which you can spin up a box, I would say is like 10x easier than Parallels, VirtualBox, any of those things. Because you don't have to separately download an image, define the storage medium, all that crap. All you have to do is say, pull down Ubuntu 20.04 and run it, and it does it. Critically, as I said, there is no like display server. So it's really intended to run headless OSs easily. But all you have to do if you do want to actually have a GUI is just install a Windows server on the Ubuntu instance that you pulled down, and then remote desktop into it. And that all worked really well and cleanly and easily. So would recommend try out Multipass. Canonical is doing a good job keeping both Ubuntu and the infrastructure to support people using Ubuntu very healthy. So good job, Canonical. Okay. That was my active content for today. Again, I'm very sorry I don't have the fancy live demos. I hope this was an interesting discussion about URDF though, as that's kind of like the crux of the issue. Does anybody have any questions or want to talk about other related pieces of this?
So in OnShape, you said that it's being adopted in the robotics community. So do people share these like the mechanical components that you could use and compose for a robot?
You're saying, do they share them?
Yeah, so isn't it the open source version something like you have to keep your designs open? Or the free version? The free versions you have to share your designs. It's something like that, right?
That's correct. Yeah, that's their premium. Well, their free model is nothing private. But if you're a startup, you're paying for it so you can have private data. Yeah.
The question of like RDF versus NVIDIA sort of, I guess, theme description, to the extent they're complementary or competing or whatever, that whole space of standards, you said there's like demand from like industrial robotics sector for something like that, and then you've also got these startups and hobbyists and sort of, and then NVIDIA seems to want to own the space. What's your sense of like, is a good open standard likely to emerge and stabilize in the space occupied by these sort of competitors, or is it going to end up getting captured by like NVIDIA's preferred format and outcome? Like, which way are things tending?
Yeah, I mean that's the multi-million-dollar question, right? That's I don't know that I'm really currently informed to answer that.
But like,
I started
principles, what would you think? Like, if you could think in terms of like comparable spaces that have gotten vaguely standardized, I don't know, like maybe machine tools or something like that. Like, what's sort of your informed expectation? And the reason I'm sort of curious is robots seem to be like sufficiently diverse that the standards competition is going to be very different from I don't know, purely software standards. So it's to me, it seems like there's more centripetal forces, I don't know, tearing it apart, and less opportunity for one big company to capture it. But that might be just wishful optimism.
There's a lot of things to say about that. I think the first foundational consideration that you have to understand about robotics is it is so heavily touched by all the PhDs in academia. That is a unique property, I would say, over some of these other comparables. So like in the case of industrial automation, industrial controls, there's no academia, and the acceptable entry points for something in industrial automation is like really good and polished. It's not like scrappy, crappy, prototype. It's like all of these industrial protocols and standards. There's huge, so that is something that's completely true. It's a good one to look at. there's a myriad of different industrial protocols and standards. And if you are a company trying to get into industrial automation, almost universally, you're going to support other people's protocols, or pick any bin of the common standards, such as like Ethernet IP, Ethernet PowerLink, EtherCAT, CANopen, like Profibus, Profinet. All of those standards you need to support, because if you don't support them, you will have no intercompatibility and then no customers. So you're fully incentivized to support the intercompatibility so that you have access to the ecosystem. Especially because a lot of the vendors that make industrial automation stuff, they don't do everything. They'll do only sub parts of the system. So one person might only make IO. One person might only make cameras and sensors. One might be weigh scales only, but they have to be compatible with that standard to be able to plug into the PLC or the control logic that's from a different vendor. I have a friend that was, he used to work in the Tesla factory, and he's like, yeah, sometimes we'll buy it. Like, this isn't about the Tesla factory. He has another thing now, but he's like, sometimes I'll buy industrial control hardware from a different vendor just because it's easier to set up and it's compatible. So it's like, I have an old controller that's kind of like, you can't change it, but then you need to change the machine or add on a new part of the assembly line. They'll use a different set of hardware that's easier to set up and configure, but it's still compatible. And so there's like fragmentation just out of ergonomics in industrial automation. And that's the power of supporting the open.
That that's partly because, yes, they have incentives and wouldn't have customers otherwise. But another feature enabling that is there is no core strategic component that's, if you control that, you can, it's like, no one ring to rule them all. And there are other, like, x86 as a processor standard, it's like a centralizing one ring to control them all. So it induces like control over a fairly large ecosystem. And I'm wondering now I'm sort of arguing the other side, I guess. If it turns out that GPUs are sufficiently like the one ring to rule it all component in robotics, then I guess NVIDIA has like a thing to grip and control the whole environment. But if it turns out that robotics, the new robotics you're talking about, is sufficiently fragmented that no one piece can rule the rest, then I think what you're talking about in industrial automation, that can start to happen. And the academic piece, I don't know that it makes that much of a difference, because once it exits the sort of like scrappy academic stage, the same incentives kick in, right? But yeah, I guess one of the key questions is GPU sort of like the one ring to rule robotics or not, or something else?
Yeah,
like powerful motors or something.
Yeah, so let's talk about the counterpoint in industrial automation, because industrial automation does have the very common, like, really quick tail. There's two gorillas in industrial automation. One is Rockwell Automation in the United States, and the other is Siemens. Those are the two huge companies. They are gigantic compared to everybody else, literally everybody else. There's a long tail of smaller companies, and some of them have gotten to be pretty serious contenders, namely Beckhoff. Beckhoff, I would say, is like a really, really big contender. Siemens and Rockwell could be like, nope, we're going to have our own standards proprietary. We're going to have our own proprietary standards now. The only hardware that works with our hardware is our hardware. They could do that. I don't think it would be in their interest. And now, so to talk about the NVIDIA comparison, which I think is relevant to the industrial automation, again, because they make tools, they make the shovels. They don't actually build the end product. They make the tooling and the infrastructure to make the machine. Why is academia relevant? So nobody goes to production with ROS. And when they do, they quickly figure out that was a bad idea. Cruise very famously used ROS 1 for quite a while. I think out to like maybe 2019. I feel like did I post a link in the Discord about this? I think I did. There was a video. I think I posted a video in the Discord with it was a cruise person talking about using ROS and why they did and why they didn't. As far as I'm aware today, it's completely gone, and for good reason. It's still like really not intended for production. Now, if you're not in production, there aren't that many alternatives to ROS if you want to get a prototype kind of whipped together quickly, I would say. And that right there, the fact that there are these two independent worlds, these two different phases of the life cycle, that I think is a key distinction from industrial machinery and robotics, because industrial machinery, the proof of concept is still the production hardware. Like all the tooling is the same. There isn't like a ROS of industrial machinery. That's not a thing. And there's no academia in industrial machinery. Like you don't have a bunch of PhDs, like, you know, with different incentives and kind of like goals, building industrial equipment. Industrial equipment is like has a singular focus on like industry and output and production. And that's like a very powerful unifying force, I think, especially when it comes to standards and incentives. Robotics has this whole other world. There's like production robots that actually do stuff, and then there's all of the R&D and research, and they have to share the same tooling. And so right now, this tooling is being pulled in two directions. So this is why URDF, has huge adoption. There's this thing called ROS that researchers use, and a lot of startups use in the early days. But then you have to rebuild all of it and throw all that out and take a different approach once it grows up a bit more. And that's probably a hot take. I think there's a lot of people in the robotics industry that would say ROS is like good enough for production in a lot of cases. Like I think a lot of ROS 2 was born out of that concern. And there's also ROS Industrial, which is a whole organization and group dedicated to industrial users of ROS. A lot of which, by the way, interacts with these industrial automation systems. That's like a big part of ROS Industrial, is interfacing with Siemens and Beckhoff and all those. I don't think NVIDIA has the pull to say we're going to be the standard and this is how it's going to be. The other thing that happens a lot with robotic startups and smaller companies is they'll use ROS or some other tool, they'll outgrow it, they'll make a new thing, and then they'll share it. And that is a loop. So that cycle, I think, has contributed a lot of things. Like a lot of the ROS industrial community and group are companies who just so happen to value collaboration with other companies, and that's why they're actually contributing their output back out to have cross connection. And I don't think there's any one organization that could pull it one way. There's just no way. Like NVIDIA has been trying. Like Isaac isn't a new thing. Like Claire Delany she started first working on Isaac, I think 6 years ago, and it's just now. It's literally like in the past couple of years, like or 1 year even. I think it's just now starting to become more of a thing. And I have a friend at NVIDIA that I can't say a lot of the stuff that we talked about, but just like NVIDIA is also figuring it out too. Like it's the same thing, because they're used to selling, they're used to selling like graphics cards. That's what they do, right? They're a hardware company. They make hardware. So I think for them to have all of this software platform, it's like new. It's very new to them as well. It's almost like NVIDIA is a startup that happens, like the robotics focus portion of NVIDIA is a startup that happens to be backed by a gorilla. So it's not like they even themselves have this inordinate amount of pull over any other robotic startup, I would say, at some level. And yeah, there's no amount of photorealism and Isaac gems that they put out that has pulled researchers away from ROS in the early days. And I think it's, yeah, like,
Have you
does that
seen
answer your question? I feel like I've been ranting a little bit.
have you
No, I
seen
mean, that's
people
what I was
outside
looking
of
for, and yeah, you addressed it, so thanks. Yeah.
have you seen people outside of NVIDIA using NVIDIA tooling? Because I only hear it from them.
Absolutely not. Well, wait. You're saying, like, have I in the wild met a company
Yeah,
that's like, oh, we're using
the NVIDIA stack. Yeah.
their stack?
Or
I think I know of a couple, but I haven't like recently had a thing, met somebody that's like, oh yeah, we're like in Omniverse. That's not a thing that I've heard. No, not yet. It comes up a lot. It does come up. I ask about it. Other people ask about it. It comes up, but it's not like a default yet. If that's at all a barometer. Like, and yeah, I mean, it's been coming up for years. I think so. The photorealistic simulation, and the, Eric, I know Eric's done quite a bit with this in Unreal. So one of the other things learning more about Omniverse that's pretty important is like you can have photorealism, but then there is this question of the synthetic data that you're generating being good, because like when you have the robot in the simulation, you need all the sensor output to be like good so that you don't have this big gap from sim to real, right? That's kind of like a key thing. And one of the really, really common sensors we have on robots today is LiDAR. So for LiDAR, synthetic LiDAR data to be really good, it needs to be good at like ray tracing, hitting the thing, and providing that synthetic data back in a high fidelity way. And I know that's something that NVIDIA has tried to do really well in their environments to facilitate like being an advantage over something like Gazebo. Because I know all these other packages do it, but especially I think in more complex environments, it's harder to make sure the synthetic data is really good, especially accounting for things like reflections, right? Like if you're trying to test your LiDAR in a glass building, that's like kind of a non-trivial thing to simulate because all of the optical properties of the material have to be right. Like a good example of LiDAR having issues is you're trying to make a robot forklift, and sometimes the LiDAR can't see the forks if they're too polished because they're like mirrors. And this is like really dangerous. So that's an example of something that you might want to have like a really good simulation to help you catch that issue in the transition. But no, there's not a lot of NVIDIA stuff and NVIDIA stack stuff in the wild. That said, everybody uses NVIDIA hardware universally. Everyone. I haven't not had somebody use NVIDIA hardware that I've met for like a year now. Like literally every robot company has a Jetson of some shape or form. I had a demo a few days ago from a company called Carbon Origins, really cool company. They're building a VR telepresence platform. So I actually sat here in my living room and put on a Quest Pro and drove a robot around in Minnesota. I was like driving a robot in the snow, sitting on my couch, which is pretty cool. And what hardware was on that robot? an AGX. That's what it was. It was an NVIDIA AGX, streaming 4 cameras to a cell tower in Minnesota, going to a data center, coming back to a cell, internet here, and then going right into the Quest Pro. Yeah, really, really cool demo, by the way, because it's just like, there's a lot of telepresence demos I've been around, but it was really, with the Quest Pro, it was really quite good. And they're trying really hard to get the latency down, to get it to be like extremely responsive. But that's like it's a hard problem on its own. But yeah, the NVIDIA hardware is absolutely everywhere, and nobody uses their stack still.
A quick question, rolling back on you mentioned that the ROS is not in production, and you said you shared the cruise video a few weeks back. If I consider, for example, the presentation you made last year about the new boat, okay? So
Yes.
typically the Roomba, basically the cheap robot, maybe not industrial anymore, but maybe more a higher volume. So it seems there are quite a few startups working on those new boats or something similar, okay? And isn't ROS growing there in production? I have no idea. I don't think Roomba is using ROS, okay? But do you know whether there are other startups where basically they have ROS in production, but it's not an industrial robot?
Depends on how you define production. There's a lot of robot companies that build like handfuls of robots, like 5 here, 10 there. And that's a situation where it's like, maybe you can use ROS in production. But I think the second you're dealing with, Roomba's a great example, actually, that I don't know what a current generation Roomba hardware looks like. I don't know if they have like a Qualcomm in there or what their target is. I can guarantee you it's not a Jetson, because it's way too high volume. But yeah, it's probably some weird cost down embedded processor, embedded SoC, like a Qualcomm Snapdragon. And I guarantee it's all custom. It's like they rolled their own Linux to run on it. It's, they're running their own vision stack. I do know iRobot does a lot of their own vision stuff, so I'm sure it's their own stuff. And it's not running ROS. And I think that the main constraint on that is the hardware in their case. Also, they just have enough people and money that, like, why use ROS if it's flaky when they can just completely build their own and have their own IP moat on top of it?
Well, they are way older than ROS too.
Small companies that are in production at 5 robots, yeah, totally, they're using ROS because they don't have enough people and money to replace the stack.
Okay, so by definition of production, you mean about basically the scale of the thing, right? That if it's something at the scale of iRobot, they are big enough to go beyond ROS. But if they are smaller, maybe a small delivery company and not a small company doing or starting to do delivery robots, Cruise started with ROS apparently, and after they went beyond it. Okay, but they did have a few results at the beginning. And so that's what you mean by production. It's maybe the scale then.
Yeah, although I think I'm indexing on the wrong scale. So I think the sense of scale that is a much better one to take away is the actual engineering resources at the company in proportion to how risky it would be to use ROS, or how much, call it, technical debt would be accumulated by using ROS. The autonomous car is, I think, a great example of something that scares me to death on ROS. I think George Hotz would laugh at that, like driving a car off of literally a cell phone. But like, Yeah, they actually used ROS 1 and it was like sketchy. So just like with a lot of off-the-shelf components, there's like this, organizational scale where you can justify rebuilding a stack that is more optimal in some reason that is valuable. Yeah, I think does that make sense?
It does make sense. Okay, it was just more to see whether you saw some trend because we talked about earlier. We were talking about ROS for industrial robots, okay? And so these are for me the image is manufacturing robots. The big robotic arm where we need path planning and so on, and it's of course real time. Okay, and there is big money involved, and it's a whole old industry, much older than ROS, so they already have a stack. So I had that in mind, and so I was wondering whether there is a trend where this might be changing, because we see so many big companies apparently investing on ROS 2. Okay, there is also ROS Industrial, as you mentioned. I was wondering whether something was changing here, okay? But maybe not.
Yeah, I'm not sure I have a pithy take as to like
but
there being a shift. Yeah.
It's a low-end disruption. Is there a potential for low-end disruption for something like ROS 2? Okay. But actually, I don't see that. Okay. So because in one of the companies where I'm involved, it's we are building a robotic framework, and for me, I architected the software to be generic. Okay, to really be generic, to be able to handle any basically software controller. Okay, for the robots. But the team has moved more and more into, on top of my work, to build basically a ROS adapter. Okay, and it seems the only traction we get is for users, so potential clients, okay, who are using the platform through the ROS adapter and only through the ROS adapter. And so for me, I still think that building the fabric to be generic and independent from ROS is the right thing to do in the long term. Okay. But I'm trying to read more of the market, market for me that is, I see from a distance basically, okay, and to see where it's going, whether ROS is here to stay basically, because if it's here to stay, maybe for that company, no need to keep the code very generic. It's more work, things like that basically, okay. So I have my question has this part of a bit selfish perspective, okay. But generally, I'm also wondering because I see so many big companies, Amazon and so on, putting significant effort on ROS. If we take also the simulators we've reviewed recently, Unity and ISAC, Gazebo 2, everything's integrated with ROS. Okay? So it's clearly for facilitating R&D, experimentation, and so on. For that, it's great. Okay? But it would make sense that something that is R&D, we would just push a button and it's in production basically. Okay, I simplify a lot, but that would make a lot of sense. If we are doing all the R&D on ROS and after we have to basically tear it apart and start from scratch to go to production, that's any benefit we would have had by starting with ROS just vanishes.
Yeah, ROS is just glue. It's glue. That's what it is. One of the key things, with the robotics company is this like time to magic, like amount of time to get to the magic. Because like when the robot does the thing the first time, everybody's happy, warm fuzzy feelings. Your investors are like not as sick and whatever. So it's like time to magic is so important. And ROS is the glue. It's like the duct tape to just go fast and connect stuff. And I think that's the other actually really good point to make about NVIDIA and ROS is like ROS is intentionally non-specific so that you can glue together anything, which is like a fundamental challenge of robotics. is it's just all over the place. Versus NVIDIA doesn't like, their stack doesn't necessarily provide as much extensibility to support all these random hardware things. But yeah, the time to magic is so important, and I don't think there's anything else that has the same time to magic ability, and it's here to stay.
Indeed.
It's not going anywhere. The lowest time to magic robot ever would be the ClickBot. I think I've shared it before, right? The modular robot,
Yes.
you can literally click together.
Yes, yes. We
So
have it
that's
in
like the vision. Yeah, so the ClickBot is the vision. ClickBot also ClickBot does not have a ROS bridge that I'm aware of, by the way, for what it's worth. But I think that's the vision that everybody is going for, and ROS is the stack that kind of allows those interlinks at the software level that nobody else does. And yeah. Anyway, I think we're over time.
Yeah, thank you, Joshua.